So stoichiometry. Introduction to stoichiometry. Stoichiometry is the study of the quantitative relationship among the amounts of reactants used and the amount of products formed in the chemical reactions. So we're looking at the amounts of the reactants versus the amounts of products. And so an example is of a Betty Crocker recipe. When we're using the Betty Crocker box, the baking mix, it requires us to use 3 eggs, 2 tablespoons of oil, and 2 cups of water. And this combination will help you make 24 yummy cupcakes. So really, balanced chemical equations are also similar to cooking because we require a certain amount of each of our ingredients to make the product. And so for this first question, example 1, how much gas will be produced if there is excess amount of water available? And so right now we have a mass of 0.64 grams of calcium, and we want to know how much gas is produced. And so we don't know how many grams of H2 is possibly produced. So what we can do is use our idea of the moles and use our mole-to-mole ratios that our balanced chemical equation gives us to find the amount of gas that is formed. So the first step is to balance the equation. So let's see. Calcium, there's 1 calcium on the left as a reactant and on the right. Hydrogen, there are 2 hydrogens on the left, but there are 4 hydrogens on the right. So we would need to put what in front of the H2O on the left? 2. We need to put 2 in front of the H2O so that there are 4 hydrogens on the left side of the equation and 4 hydrogens on the right of the equation, of the reaction equation. And there are 2 oxygens on the left and 2 oxygens on the right. So first step, we have balanced the equation. Second step. So we need to get the moles of the calcium that we have. And the reason we're looking at the 0.64 grams and we're mainly looking for the moles of calcium is because we have enough of water. So we don't need to worry about that part, so we can focus on the calcium. So from lessons before, we either use the equation. So the way I remember it is that molar mass is mass divided by mole. So you can either use the equation that the pyramid gives, or you can use the mole train. So I usually like writing the mole train, but before we use the mole train, either way, we do need the molar mass. So the molar mass is, according to the periodic table, and it may vary depending on the version that you're given, but the one we're using is 40.08 gram per mole for calcium. All right, so that's our first step, and we need to make sure we're finding the number of moles. So according to my equation, I have N equals small m, mass divided by m. So you can use that equation, or the way I like it, use the mole train. So I start off with 0.64 grams. I need to get rid of the grams, and I need to get the amount of moles. So I'm going to put the 40.08 grams on the bottom and 1 mole on the top. The grams will cancel out, because anything on the top and the bottom will cancel out if their units are the same. And so the number of moles is, put that in your calculator, so you're doing 0.64 times 1 divided by 40.08. And you're going to get 0.015968063 mole. So you may use about 4 digits, 4 to 4 decimal places for the amount of moles, or in this case, I've used kind of the more exact and precise number. So right now I have the mole amount of calcium, and it's a good practice to write down what element or what compound we're talking about. And then we're going to look back at the chemical equation and look at the ratios. So I see that 1 mole of calcium will produce 1 mole of hydrogen gas. So that means that I have for the mole amount of hydrogen gas, I have that exact same number because it's a 1-to-1 ratio. So I have 0.015968063 mole of hydrogen gas. Okay. All right. So that leads to the third step. So first I balanced the equation. Second, I found the mole of calcium, the reactant. And third, I want to find the amount of hydrogen gas, my product. And what's going to determine that is the amount of moles I have. So I have that many moles of H2. And again, you can refer to the mole train or the equation. So for mass, I have molar mass times mole. So, or in which case, I want to use a mole train. So I want to do, so I'm going to switch it around so that it matches to what I'm saying. So 0.015968063 mole H2. I want grams at the end, and so I'm going to need the molar mass of H2. So I'm going to stop there and remember to write the molar mass of H2. So all you simply do is refer to the periodic table, and it should say that the atomic mass of hydrogen is 1.01. So times that by 2 and you get 2.02 gram per mole for hydrogen gas. And so we get 2.02 gram divided by 1 mole. The moles cancel out, and I'm left with the amount of hydrogen gas in grams. Put that in the calculator and you get 0.0322542 grams. Okay, so if we're, let's say, writing it to 3 significant digits, I have approximately a mass of 0.03323 grams of H2. And so as my therefore statement, I have therefore the amount of gas produced is 0.032 grams H2. Okay. So first step, balance the equation. Second, find out the mole amount of that reactant. I have excess amount of H2O, so that's not determining how much product I'm producing. And third step was use the mole to mole ratio that the balanced chemical equation gives you, and use that idea to find the mole of H2, and that will help us find the mass of the H2 based on the number of moles using the molar mass. So that's it for question 1.